All right, so I want to talk about inequalities with absolute value and quadratics. So your suggested exercises are 3, 13, 17, 21, and 29. The key points are going to be test value, which you're going to be dealing with a lot in the upcoming lessons. I'd like for you to look at theorem. So this is THM, it's short for theorem. Okay, that's what's going on here. Theorem 2.4 on page 211. And you also might want to review section 0.4. So we already talked about some of this stuff in section 0.4, but just briefly. So now we're going to touch on it again. All right. I would also like for you to work through examples 1 through 4 and 6 in the book. So this is more than I normally give you example-wise, but I think there are enough things happening here that it's a good idea to sort of slow down and go through this section carefully. I think the general idea is fairly straightforward. It's just that if you aren't careful, you can think you understand it better than you do. So let's do an example. Solve for x. And here I'm going to be pesky and I'm going to say an answer in interval notation. So on a quiz or an exam, I probably won't specify interval notation, but I just want to do a little bit of this so that we're sure what means what. What means what? That's not a very good phrase. So the absolute value of x minus 1 is strictly less than 2. All right, so solution. We want to solve absolute value of x minus 1 is strictly less than 2. So we're going to employ this theorem 2.4, which I talked about in section 0.4. I talked about the technique. I didn't call it theorem 2.4. But when we have an absolute value less than or equal to, we can write the absolute, we can write the absolute value in the middle and say it's less than 2 and greater than negative 2. So if you'll recall from the previous, from this previous section where we had, where we had this, where we did the plus or minus like this with an equal sign. So this is the inequality version of that. So instead of doing a plus or minus with an equal sign, we've got to do the plus or minus with a not equal sign. Okay, so if it's a less than, if the absolute value is less than something, then you can do two simultaneous inequalities with 3 parts like this. So this, now that this is in the middle here, these absolute values turn into just parentheses. That's sort of the key point. I think that got lost in my explanation there. Sorry about that. We're going to just turn those into parentheses. Okay, and so now I can just add 1 to each part. And I'm going to get negative 2 plus 1 is less than x minus 1 plus 1 is less than 2 plus 1. And of course these cancel, so I end up with negative 1 is less than x is less than 3. And in interval notation, that would be negative 1 comma 3 in parentheses. So like I said, before I was just saying answered however, but for this one I asked specifically for interval notation. So just so you know what interval notation is, what it looks like. That's interval notation. Okay, another one. Solve for x. Answer, in interval notation. And this is going to be absolute value of x plus 1. Let's make these nice and tall. Is greater than or equal to 3. All right. So here we don't get to just unfold. Like I like to think of this as unfolding. You're going to hear me say unfold. Because it's like I've got this thing, it's like this, and then I unfold it, and it goes flap. Okay, that's how I visualize the less than sign. So, and then when I unfold it, it's like two sides here with the juicy center. So with this, I don't get to. What I've got to do is just two cases. So we've kind of seen this before. So if I've got x plus 1, solution. X plus 1 is greater than or equal to 3. Well, either we have that x plus 1 is negative, or we have that x plus 1 is non-negative. So in the negative case, then we need to deal with sorry, I was making sure that I got my equal sign right. In the negative case, we're going to have negative x plus 1. Well, goodness. Negative x plus 1 is greater than or equal to 3, right? Because if the thing that's inside the absolute value is negative, then we multiply it by a negative to get the absolute value out of it. And so here, now I want to solve for x. So I'm going to multiply both sides by -1, and I get x plus 1 is less than or equal to -3. And this is because I multiplied by a negative. And that means that we flip the sign. Now here I subtract 1 from both sides, and I get x is less than or equal to -4. So x is less than or equal to -4 is part of my answer. So it's either this, remember there's a big or here, or we have that x plus 1 is greater than or equal to 0. And in that case, the absolute value of x plus 1 is just x plus 1. So x plus 1 is greater than or equal to 3. Subtract 1 from both sides. I have x plus 1 greater than or equal to 2. And that's the other half. So I want to stop and isolate something. Some of you right now are saying, wait, if I know that x plus 1 is greater than or equal to 0, why does that mean x plus 1 is greater than or equal to 3? So I want to connect this. When I have the absolute value of something, I have that the thing inside the absolute value is either strictly less than 0 or it's greater than or equal to 0. These are two separate cases. So this is one case, this is another case. If the thing that's inside is strictly negative, then we look at this, but with a minus sign up front. If the thing that's inside is not negative, then we just rewrite this equation. Okay? So if you're kind of on autopilot and just writing down what I'm saying, you're going to see this line followed by this line and be like, wait, what? So I wanted to just kind of stop and laser in on that for a second. All right, so we're almost done. We know that our answer is either this or that. So how do we deal with an or? Well, we're going to write negative infinity up to 4. And this is inclusive. Union 2 up to, this is a -4 here. Let me just get in here and clean this up a little bit. -4. Union 2 up to infinity. Notice that we're never including the plus or minus infinities. Okay? So this is how we get, this is how we deal with the absolute value greater than or equal to. All right? So I want to do, these are the kinds of things that you can expect from me. I want to show you another example of something that I'm not really fond of, but I just want you to see how it works. So I'll show you quickly, and I don't plan to do a whole lot of stuff like this. So again, solve for x, answer interval. So answer an interval notation, and this one is going to be absolute value of x plus 1 is greater than or equal to 3 minus x. And the solution here is going to be to graph both and watch what happens. Now, you could, of course, you could run this same sort of regime where you could say, well, if x plus 1 is negative, we're going to do this thing. If we're going to do this thing. If x plus 1 is non-negative, we'll do this thing. And it's just that you're going to have an x over here on this side when when you're going through these. So you can solve this one. You can solve this equation, inequality, the same way you solve this inequality. I'm just going to show you another way. And the other way is, we'll just zoom in here a little bit. We're just going to graph these both on the same axes. I'm going to go really quickly because I don't expect to do this type of thing too often. So to graph absolute value of x plus 1, it's like the absolute value of x except shifted to the left by 1. So we've got this. Okay, and this is, of course, the absolute value of x plus 1. Now to graph 3 minus x, this is a line that goes through, this is, if we think of this as y equals mx plus b, then my m is -1 and my b is 3. So I'm up here at 3 and I'm going down at, with a slope of -1, so I go down like this. So this one goes like this and like this. This one goes like that. And the question is, when is x plus 1 bigger? Well, when is absolute value of x plus 1 bigger? Well, it's smaller. Sorry, this is 3 minus x. We notice that it's smaller here because we have this line would go on and stay above. Now this line's getting closer, but this line's still higher. And then they cross right here at this point. Now, if this was, with nastier numbers, this might be hard to see, but we can hopefully just view just by counting, because I've graphed this carefully, which I don't really like to do, but hopefully we can see that this intersection point here is 1, 2. If you don't believe me, we can just check when these two things will be equal. And when, how do we know which piece of absolute value of x plus 1 to use? Well, we're greater than 0 here. So this absolute value of x plus 1 is greater than 0 to the right of -1. So greater than or equal to 0 to the right of and including -1. So we just set these equal to solve for where that point is. X plus 1 equals 3 minus x. This is just kind of scratch work. So I've got 2x equals 2, x equals 1. Okay, so that's how I get the x value here. And of course, if I plug in x equals 1 to this side or this side, since they're equal, I'm going to get 2 as the output for either side. Anyways, because this line is going down till infinity and this line is going up till infinity, then from here on over, I'm going to have that this side is bigger than or equal. And since it's bigger than or equal, we'll include this point of intersection. So the final answer is going to be 1 to infinity, including 1. And you might say, wait a minute, what? But don't they cross at 2? No, they cross when x equals 1 and y equals 2. We're solving for x, and we need to know what y is to solve for x, but we don't need to explicitly answer with the y value. Okay, so hopefully you can see why I don't really want to do a whole bunch of stuff like that. I might ask like one question like that throughout the semester, but I want to kind of avoid that because I think it's a good question. You should know how to do it, but I think it's a little bit more complicated than we really need to get into for most things. So you might see one question like that, but I'd really have you more focus on questions like this for my class. All right, moving on. So let's graph just a couple of. Let's solve just a couple of quadratic inequalities. So I'm going to do again solve for x. Answer in interval notation, and this is going to be x squared is strictly less than 2x plus 3. Now the way I want you to deal with these is set this, try to figure out how it would look as a quadratic equal to 0. Okay, so this 3 is getting a little funky. So I'm going to try to solve and get a 0 on one side, and just because I like for my polynomials to start with a positive coefficient, I'm going to move everything over to the left-hand side. So I've got x squared less than 2x plus 3, and I'm going to subtract 2x plus 3 from both sides. And this is going to give me x squared minus 2x minus 3 is strictly less than 0. So I don't know exactly what's going to happen here, but what I can do is now consider the related equality. or equation. So this is going to be kind of like side work. X squared minus 2x minus 3 equals 0. And I'm going to factor this. Okay, what is this going to factor into? This is going to factor into x minus 3 times x plus 1. Now, if you want to pause the video and check that that's indeed what it factors into, but what do I know about this? Well, I know that this is a quadratic, so I can do a quick sketch, and I know it's going to be either a parabola that opens up or opens down. Now, if the coefficient is positive, smiley face opens up, right? So I know that I'm going to have a parabola that opens up. Where does it cross the x-axis if it crosses the x-axis? Well, by the zero product property, I know that if the product of two things is equal to 0, then either one of them or both are 0. Well, if x minus 3 is 0, that means x was equal to 3. If let me clean up these axes here a little bit. Let's use some movie magic. If x is equal to 3, then this product equals 0. If x is equal to -1, then this product is 0. So I know I've got a smiley face that goes through these points. Secret math teacher tip. If your graph clearly does not go through the right point, you make the point bigger. If only real life was like that. Okay, so we know we've got something that's a smiley face like this. Now, I don't need to know the vertex of this parabola, although I could compute it. All I care about is whether it's above the x-axis or below the x-axis. So by sort of looking at this graph, I can see when this thing is above or below the x-axis, right? Okay, how do I do that? Well, I look here, it's above the x-axis, so I'm going to put a little plus sign here. Then it's 0 here, and between there it's negative because it's below the x-axis. And after this point, it stays positive. Okay, so from here, I can answer when is this thing negative? It's between -1 and +3, and there's my final answer. That's one way to get to the final answer. Now, if I don't remember how to sketch, then I can go back here to my, so this is like solution 1, and this will be solution 2. What I could do is I could factor this again. I get x minus 3 times x plus 1 less than 0. And again, I'm looking for where this thing is negative. Well, I know that it's going to be equal to 0, so I know that this will equal 0. X equals 3 and -1. So I'm going to pick test points. So I'm not really defining test points. To pick test points on either side of each 0 to test if this polynomial, well, I can say quadratic, is positive or negative. Okay, so the test points are just going to be, I'm going to pick numbers around but not equal to 3 and -1. So let's plug in what if x equals something less than -1. What if x equals -2? Well, then this product is -2 minus 3 times -2 plus 1. This is a negative times a negative, and that is positive. Okay, and what that tells me is the interval less than -1 is not going to be negative. It's going to be positive, so it's not going to be something that I want. Okay, let's check now x equals, so something in between -1 and 3. Let's check x equals 0. So I plug in x equals 0. I got 0 minus 3 times 0 plus 1, and this is a negative times a positive. Notice I'm not actually computing what the value is. I'm just checking whether it's greater than or equal to 0, or greater than or less than 0. So this is less than 0, which means that between these points, I do satisfy my inequality. And finally, let's pick something bigger than 3, so x equals 4. And I've got 4 minus 3 times 4 plus 1, and that's a positive times a positive, which is positive. So I don't care about this one, I don't care about this one. And which interval does this correspond to? Let me draw a real number line might help. Again, 0 just for reference. We got a 3 here, we got a negative 1 here, you know. I guess I could have made the 3 a little bit closer to 3. What did we check? Well, we checked negative 2, so we know it's going to be 0 here, we know it's going to be 0 here. We checked negative 2, we checked 0, and we checked 4. Okay, so this didn't work, and this didn't work, but this worked, which means the interval, when this thing is negative, is going to be between these 2 points. So the final answer is negative 1 up to 3 exclusive. And what do you know? That's what we got using the graph. So I just want you to see these as two similar yet different ways of getting to the same answer. Okay, last thing I want to do, and this one's a little bit perverse. So again, solve for x and answer an interval notation. And this is going to be, this one's fun. Absolute value of x minus 2 is less than or equal to x squared minus 4x plus 4. Okay, so this one, again, solution, this one's a little far out. Okay, so again, don't expect something quite this difficult. Let's notice that the right-hand side is x minus 2 quantity squared. So we're probably in for a wild ride. Okay, so let's graph both sides. So the left-hand side, so LHS, this will come up again later. Left-hand side, LHS, is the absolute value of x minus 2, which is just the absolute value shifted to the right by 2. Okay, so we've got the absolute value shifted to the right by 2. Okay, no big deal. Now let's look at the right-hand side. And I notice that this is x squared minus 4x plus 4 factors into x minus 2 quantity squared. Now, if it's not obvious to you that this factors like this, I need you to practice factoring, okay? You don't have to see it immediately, but you should you should practice factoring enough that when you see this, you can think for a few seconds and say, hey, I bet this is factorable. Just if you do enough factoring, you start getting a sense for, oh, I bet those numbers have something that I can factor, and then you know when to try it and when to just say, that's probably not going to factor over the integers. Okay, so x minus 2 quantity squared, which is going to be, of course, a parabola shifted to the right by 2. So this is a parabola shifted to the right by 2. Okay, now how do we figure out when the parabola is going to be above or below this absolute value thing? So this is what we've got. Well, what we can do is we can try our test points again, and we can try our equations again, or we can just graph a picture. And so if we look carefully at this graph, let me do a better job of graphing. If I look really carefully at this graph, not quite what I'm looking for. Oh my gosh. I keep coming up off the point that I want to hit. There we go. Beautiful. I'm really careful with these, and then this is going to be a little bit harder. But if I graph my parabola, wow, the left half was so beautiful and the right half is just not working out. My hand keeps catching on the thing. We're going to see that these cross right here at 1 more and 1 less than those points. Okay, and you can figure this out by you can also check this by solving the equation, which is x minus 2 quantity squared equals x minus 2 in absolute value. when we solve this equation, we're going to get, of course, here it's either plus or minus this thing squared. So how does this work out? Well, so we've got x minus 2 equals plus or minus x minus 2 quantity squared. So I divide both sides by x minus 2, and I get 1 equals plus or minus x minus 2, right? Which is, oh dear, I bumped the button, which is, this either goes to 1 equals x minus 2, or 1 equals negative x minus a minus is plus 2, all right? So then this becomes x equals, if I add 2 to both sides, x equals 3, and this becomes now, if I subtract 2 from both sides, negative x equals negative 1, which gives me x equals 1. So we can see here that this is going to be the point x equals 3, and this is going to be the point where x equals 1. These are both going to equal 1 here. Okay, so what's the question again? When is the parabola bigger than or equal to? Well, they both hit the x-axis at the same point. So the answer is to the right of 3, to the left of 1, and also right here at 2. So that is negative infinity up to 1, union the set containing the element 2, union 3 up to infinity. Okay, and again, this is a little bit harder than I would probably be giving you on a quiz or exam, but it's good to go